Alright, Deltix round, spring 2021. This is Division 1, so I probably won't be talking too much. But yeah, hopefully I do well. Let's see. I'll look at B first. While trading on his favorite exchange trader, William finally found a vulnerability. The number of internal variables is always an even number. William understands that with this, every action attracts more and more attention from the security team. Okay, so he does this. Perform assignment I and perform assignment J. It's always even. So we can replace a number with a sum of another number, or we could subtract another number from it. And we want to make all of these numbers negative. Okay, I see. ABCD. If for example, this becomes A plus D and then D. And then if we subtract this from here, we get A plus D and negative A. Can we swap values around? No. We can't. But A plus B, and then this is like negative A. If we take this value and then add it onto here, then we can get D and then negative A. So this is okay, I think this could work because it guarantees that n is even. So it's like for every pair of two integers, it's 1, 2, 3. Wait, hold on. No, this is 1, 2. It's exceed 5,000. 1, 2, 3. And then we could do something like we add this to the here. And so then it becomes, this adds on to here, so then it's D minus A, negative A. This can subtract from both sides. Yeah, and so then it becomes D minus A, and then like negative A minus this is just negative D. And then we add these together to get negative A, negative D. This took 1, 2, 3, 4, 5. Wait, 1 move, 2 moves, 3 moves, 4 moves, 5 moves. No, it's 6 moves. It's almost 5,000. Oh, but it's divided by... In 6 moves, we can fix 2 variables. Okay, yeah, this should work. System.print SV. Is this... Okay. Array doesn't matter as well. So pretty much what we can do is, because we know n is even, Oh, frick. I is strictly less than k. Wait a minute. Does this hold if I is strictly less than j? Okay, so we can add on to the first number or we subtract from a later number. Okay, so we add on to the first number. This is okay. We subtract from a later number. This is okay. We add on to the first number. This is okay. This we add on to the first number, which is okay. We subtract from the later number, which is okay. And then we add on to the first number, which is okay. Okay, so this works anyway. Thank God. I didn't realize that condition, but my way just happened to work for that. So pretty much what we do is and j is equal to I plus n over 2. Because we know n is even. So then we could just do moves.add. Okay, wait, so this is an add, this is subtraction, this is addition, this is addition, this is subtraction, this is addition. So add. So we're going to do moves. Type 1 is addition. To ij, add move 1ij. Size over 3. Okay, we got B. Let's look at A. Problem A. William really likes a cellular automation called Game of Life, so he tries to make his own version. For simplicity, am I recording? Okay, yeah. So you would like to make this game of some sort. Evolution development is dead, and exactly one alive neighbor. It will become alive. First state, third state. Oh, okay, this is not that difficult. It's just pretty much implementation. Use a Q or something. This one's not print SB. So int n, and then then, okay, and then the input, so it's just we just do this. Just for the memes. Actually, wait. Hold on. We only want to do it. I'll just use the Q. And so do 4. New int n. No, if array at I is equal to this, distance at I is equal to 0, q dot at I. And this is equal to n plus n, or I guess it's equal to infinity. Okay, if cur is strictly greater than 0 and this distance, then we can do this. N is small, yeah. So if distance at I is strictly, no, if it's less than or equal to m, then we append something. Is that correct? Oh wait, that's not even correct. Okay, hold on. Exactly one alive neighbor. Oh, frick. Exactly one. If 0 is less than cur, and cur is less than n minus 1, and max of distance at cur Okay, I don't know why this is not working. I'm just going to move on to problem C for now. It's not worth my time on that, spending my time on that problem. William is a huge fan of planning ahead. That's why he started his morning routine by creating a nested list of upcoming errands. A valid nested list is any list which can be created from a list that does one item by applying some operations. Add an item here. Starting a list of deeper level or continuing on current level. Operation can only be applied to a list that does not contain two identical elements afterwards. What? Okay, wait, is A like easy? Okay, A is apparently easy. I'll just go back to it. If it's like a million, 10 million. 10 million is probably okay. Yeah, probably. How do we do this? Okay, let's just delete this. Returns is equal to min n, and because if at most one character, yeah, 1 1 will become a 1, so I guess it's like n, like n iterations. If I is strictly greater than 0 and array I minus 1 is equal to 1. If I plus 1 is less than n and array I plus 1 is equal to this, if count is equal to 1. Array is equal to next. Wow, I'm really trolling, huh? What is going on? Int character next. Wait, but 101. Okay, I don't understand how problem C works yet. Okay, so we start a list. added a note section. What? Wait. Starting a list of a deeper level. This is only 2 test cases? What the hell? So we have 1, 1, 2, 3, which is what remains of your list. All items are replaced by a single number. The last number originally written in this item list. One example of a fitting list is this. Okay, so we have 2, 4, 1, 1, 2, 3. 1, 1, 2, 3. Oh, okay, so like they're all the last, we're given the last elements. List can be produced by doing this. 1, 1, 2, 1, 1. How does this happen? Adding a level. Insert item 2 by using insertion operation. Insert item 1.1. Insert item 1.2. Insert item 1.1.1. Oh, I think I kind of get it now. And you want to do these operations so that there's identical elements. Huh. It could be 1, or it could be like 1.1.1, or it could be this. So we could just do any prefix. Is the first number we always add 1? Okay. This problem, like maybe it's just a problem statement, but I'm just confused by it. Wait. 1, 1, 1, 1, 2. Okay, I guess if it's 1, and then if it's a 2, then we could just do a 2 over here. If it's a 1, then we look through his list, and we want to see like where. Okay, but we're given everything in order. I think of it like 1, 1.1, 1.1.1, 1.1.2 is like 2. Or I guess 1.2 works as well. I think you just append if it's the same thing. It's like while it's the same, it's like 1.1, like 1.1, 1.1.1. And if we like increase value, like goes 3, then we like backtrack. It's like 3, and then like 1.2. And it's like 1.2.3 or like 1.2.1. Let me try this. 1.1, 1.1.2, 1.1.3. Okay. One, 1.1, 1.1.1. Wait, but 2 and then 2.1 could work, right? And we just have 2.1, 2.2, but then if we want to go like back to 1, we could do like 2.2.1, right? Or 1, 1.1, 1.1.1, 1.1.1.2. Insert item in here. Wait, 2 identical elements afterwards. One point 1.1. Oh, but it probably has to be in that order then. Oh, okay. I think I understand this problem now. So if we do this, then we do like 1.1. Yeah, but there has to exist like a 1.1 before we put a 1.2. Right, because that's why we append a 1 at the end. Like a 1 and then a 2. Yeah. .1.1. We can never go from a 1 to a 3. Yeah. V equals array at I minus 1, then okay, I don't think they answered the question that I had in mind, but whatever, that's okay. 1.1, 1.2, 1.3, and then 1, 1.1, 1.1, 1.2, 1.2. Oh, frick, these contain the same value. One, 1, 2, 2. Wait, but that shouldn't be happening. Because then this is like 1.1.2. Oh, we just do it by dex. Yeah, lesson. Let's try this. 1, 1.1, 1.1, 1.2, 1.2, 1.2.1, 1.2.2. I'm just going to submit and see if this is right or not. Pretest 1. Okay, wait, that worked. Okay. Dude, I'm completely honest. Like, transparency here. I still don't really understand what this problem was asking. I just assumed that it worked, and it did. Okay, so weird constraints. Problem E. How many solves? Okay, I'll just look at standings really quickly. Okay, fair enough. Crypto lights. Exchange traits. William invented a wonderful device consisting of n lights arranged in a row. The device functions in the following way. Initially, all lights on William's device are turned off. At the beginning of a new iteration, the device randomly picks a light that is off and turns it on. After this iteration, if any k consecutive lights contain more than one, then this turns on. Expected value. A number of lights are turned on after it finishes working. So if any k consecutive lights contain more than one light turned on, okay, 3D. This is not D. This is D. William is hosting a party for n of his trader friends. They started a discussion on various currencies they trade, but there's an issue. Not all of his trader friends like every currency. They like some currencies, but not others. For each William's friend I, it is known whether he likes currency J. M currencies in total. And like this, I want to find the largest. Wait, what? Number of currencies, the maximum number of currencies each friend can like. Okay, this is important. We need to find the largest subset of currencies. Okay. The largest subset of currencies such that at least this many friends who like this currency in the subset. Least. Oh, okay. So it's like we find a subset and all of like there has to be at least n over 2 friends like all of them, right? So 1 and 5, like this holds true. But even though we could pick something like 1, 4, 5, yeah, that doesn't really work though. I see. Number of currencies in here, and the maximum number of currencies each friend can like. Okay, what's 2 to the power of 15? 32,000. Let's see. If there were only 15 currencies, then how would we do this? Maybe like just do a bit mask and then like decrease that number. So this. Right, so this mask is possible if the okay, so we know that if a subset is possible, a strictly smaller subset has to be possible as well. So we could just check using this, and then the way that we would check this DP would be like, for every bit, and then we know the previous answer, we would need like the count of like the mask of all these people. The maximum number of currencies a friend can like. N over 2 friends rounded up. Okay, so if it's 2 friends like this, yeah, the full subset is possible. If we have like 1, 1, 1, 1 and like that. Doodly m with n times, what would this look like? N times I guess for each mask, you need the frequency. It's like out of each set of friends that they like, you want to look over this mask. And then, add it in. And then to the end. Okay, well, they can only like a certain number of them, like a certain number of currencies. Yeah, they can only like some certain currencies. Okay, so if, for example, yeah, we're just basically looking over a mask and then seeing whether, okay, well, we know that for n over 2 friends, I think we can do this with randomized, because basically we know that for every friend has to be some subset, some like submask of that mask. And so then we could just say like, okay, if it's like this mask, if we assume like one of these friends is included in here, then we can just like, okay, how do we solve this if we assume that one of these friends is like a friend that we care about? So like, if we did that, then we only care about friends. We only care about the other friends whose mask is like a common bits, basically, I think. Yeah. So for every mask, which can go up to 2 to the 15, usually it probably won't go up that much, but let's just say it's like this, for example. Like that. And then we do, for example, okay, if we have a mask, we need to know the mask of all of these friends. And we just need to count it. So then I think it's like O of n. Yeah, it's like O of n times that. Which is definitely too much. Because it's like, what, 200,000? Yeah, that's definitely too big. And then if we're assuming this is randomized, then we have to like, yeah, if we can solve the problem, given that a friend has to be in the subset, randomization works. Maybe you can do some sort of like pre-comp where it's like we have this mask and like this mask and then everything else that belongs in this mask. With pre-comp, this could work. And then so it's like we have essentially 1/2 chance of always getting that. So the probability that we'd never find a correct friend is going to be, if we like run it 20 times, it's going to be like 1/1,000,000. Like 22 would be even more. Okay, I'm gonna try this. So I probably want fast scanner for this. Fast scanner, yeah. Long. For int b is equal to yeah, sure. Static int turns is equal to 22. Math.random times 69, 69, 69. Doesn't really matter. Plus 420. Int choice is equal to ram.next double. Like and or equal to this. So mask as I is equal to array at I and array at choice. I'm actually going to do this. because we only care about the frequency of these masks, so we don't really need array anymore. Instead, we would need something like, oh, I guess these are supposed to be longs. Set, we do distinct at boof plus plus is equal to x. Int m is int size is equal to distinct at choice. Actually, wait, hold on. But then that could screw up our probability. Right? Yeah, okay. There's no need to do this. I'll just do it by n. Yeah, because even if we hit like the same mask that like has to be, it's like really big, it doesn't really matter because it would have, by pigeonhole principle, that would be in a valid set anyway. Yeah, I think. So if we did something like this, we want to do wait, does that work? I think it does, yeah. Long mask is equal to this. We like choose a random mask. So in this case, it would look something like that. Check all submasks of choice. Okay. I want to process these masks in increasing order. Yeah. Or I guess decreasing order. So iterate over submasks. Okay. hash map log integer db log integer. Yeah. Okay, so for long m equals array at choice, m is strictly greater than 0, m is equal to m minus 1, and array at choice. I'll do 25. I guess 24. For long m is equal to this, m is strictly greater than this, m is equal to this. Collections.sort submask. For long x of mask, we push frequency in x. Oh, true. Hash map. Or I guess a long, yeah. For int b is equal to 0, b is less than. Yeah, there's at most 2 to the 15. Even if, I mean, 60 times 2 to the 15 is probably okay, right? Yeah, that's not a problem. If m and 1 lift at b, okay, well, if array at choice and 1L left lift at B, actually, wait, hold on, let me do this. Yeah, so if m and long parent is equal to m or 1L left lift at B, if frequency contains key at parent, then we push, we want to push a value. push 1. Map.get at k plus v. We push map. We have a key of m. Rect.get. Nope. Freak. If this is strictly greater than n plus 1 over 2, so if long dot big count at res is strictly less than long dot big count, then res becomes m. Oh, m. Okay. So it's this. Should be at least 2 bits. Wrong answer pretest 7. How many pretests are there? 37. What was my runtime? 124. Collections.sort at submasks. We push. Oh! Collections.reverse submasks. Yeah, that was stupid of me. That was really dumb of me. Right? Because we need to process these masks in decreasing order. What? Wait. Hold on. Wait, why did that break earlier? 2 to the power of... Should I just make this 30? I'll just make it 30 for now. Okay, so if we assume this person definitely has this, it's definitely included, then we want to count how many people are already included. Collections.reverse. Oh! This is... Oh my god. This is, This is M. God. Oh, I'm so dumb. Let me make sure I didn't screw up any variable names elsewhere. Okay, this is N. That's fine, because there's N lines of input. This is N because there's N masks in total. B, there's up to M bits. If there's up to M bits, then okay, is there submasks? Okay. Okay, yeah, because we're iterating on that anyway. If this is equal to 0, we take its parent, and then anything in here also has this. And if it's strictly greater than this, so like n is equal to 5, it's at least 3. If 4, then it's at least 2. Yeah. Okay, let's try this. Same thing, really? Wait, huh? What's going on? At least this many people like it. And I made 30 turns. Ran.x double times n. Collections.sort, collections.reverse. Yeah, I already reversed it in here. In long and masks. Over here. You push. This occurs once. Yeah. Then if this occurs. For long M submasks for int B bits. Long parent is equal to this. If M, yeah, so like if this bit is not, if it's not set, is it M? M is almost 60, yeah. And then bits dot add this. Long M. For int B, we have bits with like this many bits. It's almost 15. And then if this and this is equal to 0, then a parent is equal to this. If frequency dot contains key parent, then we push frequency, this M, and then M plus that many parents. Oh, because this can be included more than once, right? Because we have like a bit like this, it could be included over here and then here. We want to do inclusion, exclusion, or something like that. Yeah, this step right here isn't quite right. Number of ways to do this bit. got this. We get it by sum, so it's like, so new PIE step. Wait, let me make sure this is the reason why, because we have 3 bits, this is included here, and this, yeah, because like bits of 3 can be included in bits of 1. Okay, that makes sense. So for the long M in submasks, for and B in bits, yeah, because what we need over here is long total is equal to new long at P, or I guess P plus 1, because it's like a number of bits. Long K is equal to long dot bit count, array of choice, K plus 1. Okay, so int bit count is equal to long dot bit count at M. So if bit count is equal to K, then total at K is just equal to, well, total at bit count is just equal to frequency dot get M. Else, we've already added this. We need to now like subtract this. In here is equal to bit count plus 2. Negative 1. Frequency dot get M. So val plus equal to molt times, and then molt negative 1. Okay, so this should be the fixed value. Frequency dot put M val, and then we can do, I guess it's technically integer, yeah. And then we can do something like, what can we do after this? Maybe this could be a long, but the final value has to be an integer. And then we could do total at bit count plus equal to val. Oh, okay. Yeah, PIE is a thing. No, same, really? Come on, dude. I thought that would have been it. Huh. I mean, it seems to be relatively hard, so I guess penalty doesn't matter too much. But why is this not working? many masks have certain bit set? Or I guess it's like given some set of numbers, we want to be able to query that. Maybe we're not doing PIE correctly. Maybe, yeah. Oh wait, because that first step could still, PI could still break, right? So what if we do this instead? Okay, this is pretty obvious. Long val is equal to 0L. Frequency output, the total bit count is equal to here. Is that correct? No, it's not. Frequency at here. I guess the number of times that it appears itself. Yeah. Do I need to make these longs? Push frequency x and 1. Yeah. Otherwise we do this. Long value is equal to yeah, this is like how many extra ways are there? I'm gonna make up a random test case. So if it's like, if we have 7 people, there's up to 3 of these. Each person will have at most 2. It's like 7, 3, 2. We could do like 0, 1, 1, 1, 0, 0, 0, 1, 0, 0, 0. 0, 0, 1, 0, 1, like 1, 1, 0, 0, 0, 0, 1, 1, 1. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. Okay. This is kind of annoying. It's slightly annoying. But I mean, somehow we're still not doing that bad in terms of ranking. I just need to rewrite this whole thing. If I just do do this. I have masks, almost m bits. Okay, we need to get frequencies. Super mask. Because like this has to be included in the set, so it has to be some subset of this. Yeah, that's definitely right. So then what we can do is we can do for each number, if it's like set by 1 bit, each number is also set by 1 bit. So if something like 333, this is like, or wait, hold on. If it's like 111, 101011, or 110. And when it comes down to something like this, it'll be the number of frequency in here plus the number of frequency of this. Wait, I think it's because I accidentally did PIE on already updated values. Oh, okay, that might be why. Okay, I think that makes sense. I'm gonna implement this again just to be safe, but for supermask, m is strictly greater than 0, and is, wait, what is a submask enumeration again? M is equal to m minus 1 and supermask. Yeah, it's like we have these values, or I guess like this is a correct value, right? The number of ways we can do it with at least this much. Minus the number of ways we can do at least that much, minus the number of ways we can do at least this much, and so on. What if we calculated the exact value? It's like this is the exact value, and this is this exact value. But the thing is that like we just calculate all values such that number of ways we have like this mask or higher. Yeah. The number of ways we can have this mask or higher is equal to the number of ways we can do this mask, and then oh, because we weren't supposed to add total, because that doesn't necessarily guarantee that all of its bits are valid. True. Okay, that actually makes a lot of sense. Okay, so how do we do PIE on here instead? Okay, so I realized why this is giving a wrong answer. We just need to find a way to fix it. So pretty much, we need this bit turns off, this bit. We need how many bits? Like a number of ways we can do this. Oh wait, what is 3 to the power of 15? It's about 14 million. What if we just do that instead? Yeah, because it's like we iterate over all of these masks, and then we iterate over their own submasks. So it's about 14 million, and we do this like 30-ish times. That honestly might work. I want to try it. Push frequency x at 1. So for long m in ls, so if frequency contains a key of m, then we can push into dp, we can push m and push val. Or I guess more specifically, long child is equal to m in 0, child is equal to child minus 1, and m, push dp and child of l. Yeah, so we could just like insert everything directly. Get frequencies, and then we can do for rect key set. If frequency.getMask is this, if long.bitCount at res is strictly greater than long.bitCount at mask, res becomes mask. Okay, this time it's a little bit slower, so time limit is definitely more of a concern. Oh my god, this is so annoying! Oh my god. Do you know why this doesn't work? God. It's like, Jesus Christ, dude. Why? Why do you do this to us? It's like turns is equal to 30. So unless if, okay, we have this. Okay, so these are like the original masks. Maybe there's a test case where like there's a lot of values that are different. Do we return DP? Oh, because it works a little bit differently now. We need to process it like this. Yeah, because if we did DP from top to bottom, then we needed to reverse it, but I don't think we have to reverse it in this case. Oh, I'm having a mental breakdown. G. Wait, what the fuck? Problem in G? Why is this not working? Like, come on, dude. Okay, we iterate over all of the masks. We push this value itself, and these are all guaranteed to be values smaller than m. If they're guaranteed to be smaller than m, then it's like we can add it on here. Yeah. Should I just make a stress tester? I probably should. And choice is equal to this. $60, 15, m. This is n and m. This is n. Do this. This might have to print on this. long n minus 1. Take a value and we add everything above it. Child can be equal to itself. Yeah. Like this, how many times it appears, and then we also want to add it on all submasks. Then we do this, then we do this. Should I just change the seed? Or should I just leave that random? I'll just do this to see what happens. If this is strictly greater than 0, then we do this, otherwise we do this. What if I increase this to 40? We push a value of 1L, I guess. Oh, frick. Oh, my push method was wrong. Oh no. God damn it, dude. I'm just making so many mistakes that I shouldn't be making. Like, God. Can we at least work? Oh God, that might be too big, right? Oh, this value might be too big. I mean, we could tone it down to like 25 and it'll probably be fine. Because 1 over 2 to the power of 25 is, yeah, there's no way that should break. Okay, but at least we know that it's probably correct. We just need a smaller number of trials, probably. Or maybe I'm just getting Java'd. Who knows? Fun. I love it when I TLE. How fun! Woo! Poggers, dude. I love it when this happens. TLE pretest 23. You love to see it. Woohoo. Maybe we don't even need DP. Instead, we just like return frequency and then we update it in place. If child is not equal to m, we push frequency. Yeah, that like saves some hash map operations. I am using fast scanner and I'm not sure how else I could optimize it. 22, 23, 23, 23. Okay, hold on. Everything is going to be okay. I'm sure it will be. Frequency solve. Yeah, so like for a bit, it's like 14 times 20. 1 over 20. 1 over 10 is a little too risky. Do I dare risk 1 over 2 to the power of 15? Do I dare risk this? The probability is like, if there's 100, let's say there's 100 test cases, then the probability that we pass all 100 of them will be this. 90, oh god, that's literally a chance of not getting a 5-star. Oh, I'll do 16. I'll do 16 and see if it helps. We'll do 16. Test 4, 22, 23, 23. Okay, it worked. Under that time period. Dude, I wasted so many points on that problem. It's not even funny, dude. God, it's so annoying. And the worst part is that this has a chance of not even being correct. Because of just randomization, dude. God, that was so annoying. Especially given the fact that, like, I could have done, like, a lot better on that problem, but, like, whatever. I don't know what else to say. Yeah, I'm first on my friends list, so at least that's cool, I guess. Copium. Now the question is, do I just pray to God that this works? It's to the power of 16. Okay, it is just math.random, so it's like, it's not the same seed every time. But even then, it has roughly 1 over 16 chance of not working. Or no, not 1 over 16, 2 to the power of 16. Okay, like 1 minus to the power of 100. There is a 99.8 chance that it doesn't work. 0.8% chance it doesn't work. It'll probably be fine, right? I hope it's fine. If it's not, then I am a sad, sad man. Oh, you know what? I'm gonna do this. I'm gonna see if I can get 20. Because 20 is like actually like fairly safe. I'm gonna see if I can get 20, but I'm not gonna use a method for this. I'm just gonna do everything up here. Yeah, because like we're getting so few points on that problem that it's like it doesn't even matter if we resubmit. Like it literally just doesn't matter anymore. Solve. We do this. Actually, no, I don't feel like fixing it. I don't feel like fixing it. Like I'll just cope with this. Although I definitely won't lock a problem because 2 to the power, yeah, whatever. Let's see. Are there any hacks going on? Any verdict, any problem? Status, any verdict hacked? Because I don't think I'll get another problem. Okay, they're all on A. Is my A okay? I mean, I'm literally just simulating it, right? If array at I is equal to 1, next at I is equal to 1. Yeah, I'm literally just simulating it. It's not a problem. Okay, I'll try to hack this. If I FST, then so be it. Actually, no, please don't FST. I would not like that at all. But, okay, wait, what does our delta right now even look like? It's barely any better because of how many wrong answers we had. That's so sad. Okay, let's look. DP. Why are people using DP on 2A? What kind of freaks? Kind of freaks are these people? Deal. Okay, that looks exactly like my solution. So if I can hack that, then we have a problem. Count is equal to 1. If temp is equal to string, then we break. Okay, that's fair. That's fair. That's probably fine. Okay, I'll read these problems. I'll just look over them. Yeah, people are also, yeah. Have fun with problem D. I'm sure you have at least as much fun as I had. Oh my god, dude. Favorite game. Okay, back to hacking. That looks fine. What is n? Oh, just count the sum of the array, probably. Yeah, that's probably fine. What is this? So while test cases, no. Oh no, it just repeats while this change is equal to 0, Boolean flag is equal to 0. What? Wait, I think I can break this. Because it only breaks out of the K loop when flag is 0. And it's 0 whenever it seems to doesn't make any change in here. So it's like if change is 0, Boolean flag is equal to 0. Oh wait, no, it's probably no. It's fine. Because if it's equal to this, if change at I set I is equal to 1, if I is equal to 0, okay, yeah, this is fine actually. I don't think I can break that. If m is strictly greater than n, then it's n. Otherwise, it's n and m. Okay, that's fine, probably. String concatenation. Can I break that? Do I think I'll be able to break that? Because it's concatenating n times up to this. Okay, so we have n be if n is like really big, or like a maximum value, 10 to the 3, m is also 10 to the 3, and there's 10 to the 3 test cases. Oh wait, but this is guaranteed. Yeah, it's probably fine then. I don't think there's an issue. Wait, is this necessarily true? Okay, we solve. Okay, so this assumes that if a number of iterations is really big, then all of them are ones. I might be able to hack this, because if I have a test case that's like n a string, and then like something over here, 1 1 0 1 1, this will always stay 0 no matter what. It's like 5, and then it's like 42069. So if a number of iterations is strictly greater than that, and the count of all of this is strictly greater than 0, then it sets everything to here. But I don't think that is true, because in this case, if it's like 1 5 42069 11011, it should stay that way because that 0 can never change. So if it's like 1 5 42069, then I think we can hack this. Let's see. Yes, let's go. Okay. Nice. That helps a lot. I mean, not a lot, but it definitely helps. Okay, so that seems to be what the hack is. Or at least one of the hacks. So I'll just look for that in here. Okay, so I'll just skim over everything to make sure nobody is doing that. No one else, at least no one else is doing that. If S is all zeros, then okay, that's fair. Okay, that seems to be the only one that seems to make that mistake in here. Okay, hold on. Let me put this over here. So, just to quickly explain what I did over there. Pretty much, this guy assumed that if the number of iterations was really big and there existed at least one in the input, then all of the digits would become 1. But that's not necessarily true. Because if you have something like 11011, that 0 can never become a 1. So that's why you can hack this. At least that's how I hacked. That's how I hacked this guy. So yeah. Not much else to say about that. To see if I can get another one. Okay, let me first check to see if there's any other things worth hacking. Seems to just be A. Yeah. So our delta is currently plus 47. Pretty good. Honestly, pretty good. But like, it should be a lot better because I just completely trolled on this problem. I'm still kind of sad about that. But yeah, so we have this. If n temp is equal to 0, then we break. That's fair. That's fine, that's fine. Is there anything worth looking at over here? What is problem B? No, problem B is probably okay. Problem B, I don't really see a way to hack it. C and D, D, I'm not gonna lock my solution. Just because I don't feel like it. I do not feel like it. Wait, let me just make sure that the probability isn't like that bad. 1 minus 2 to the power of 16. So this is a probability that we fail any one given test case. The probability that we fail 100, no, the probability that we pass 100 is equal to this. Yeah. You know what, it's like you have to like lose a 1% chance and then get like another 1%. It's probably fine. I'm not gonna bother too much with that. Yeah. Yeah, as you can see, people. Oh wait, he's also getting TLE plus 23. Oh my god. Dude, he's also getting trolled. Let's go. We both lose years of our lifespan. Fog. Whatever. Okay, so if Si is equal to 1, we push back this digit. Okay. I can't tell what's going on in here. Okay, so I is equal to V at 0 minus 1. Wait a minute, hold on. I think I can break this guy's solution as well with the same test case. Let me just work through this by hand. Okay, so 4i, 4 is, okay, 0 to n minus 1. So if Si is equal to 1, then it adds 1 pretty much. Yeah. Oh wait, okay. No, it's probably okay because this is only the endpoint. The endpoint can never have 2 adjacent. Yeah, and I is equal to this 1 minus 1. Yeah. And same thing over here. That's probably okay. And then int difference is equal to this. Okay, so 1 to v dot size. So the elements in v in this case are 0, 1, 3, 4. So if it's less than or equal to 1, continue true. Otherwise it's 3 and 1. Oh, but it's 3 minus 1 minus 1. Yeah, so like 3 minus 1, what is 2 minus 1 is that? And he's just ignoring it. Otherwise, if it's big, then we just go on both sides of a pointer. And if it's, okay, yeah, that's correct. I don't see a problem with that. If J is equal to this, if J is equal to that, that's way too weird. Actually, wait, hold on. If J is equal to 0, what does count do? If count is equal to n, then we break. If S of I is equal to this, okay, so 1s is empty, but we don't ever use 1s at all. Wait, yeah, we never use 1s. The string of SC is equal to S, and then we iterate over this. If s at j at I is equal to 1, then we don't do anything. And we just loop through this whole thing. If count is equal to n, then we break. But he only breaks this loop when count is equal to n. So I think we can break this with a TLE, I think. Let's try. All right. I'm out here ruining people's lives. 1, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 10 to the 9, right? Yeah. What if I just do 1, 2, 3, 4, 5, 6, 7, 8, 9? I think this will TLE. Let's see. Waiting. This might take a little bit longer because it's not a wrong answer hack. Nice! Okay! So it did work. Pog. Our standings are slightly better now. Yeah. Pog, 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 pog. So, if this and count at I is equal to 1, otherwise that's wildless. Okay, when you break, do you make m smaller? No. Okay. The only time you break is if n temp is equal to 0. What is n temp? X dot size. Oh, okay, so size of temp is equal to 0. Oh, okay, so this is just a number of units that changed, I think. Yeah, that's probably okay. Yeah, because like it actually checks a string and then stops when it breaks. If flag is equal to 0. Okay, so while this is happening, flag is 0, t is s. If s at I is equal to 0, then k is equal to 0. Okay, so checks adjacent. If you can change this adjacent thing, then it sets flag as 1. It only breaks when flag is equal to 0. So as long as it does something, in s of I. Okay, that's probably fine. I don't see an issue with that. I already checked that. Let's check this one. Okay, I mean, he changed n, it's probably okay. Min, that's probably fine. Yeah, you're having a lot of fun with the problem, huh? Yeah, buddy. Friend. I had a lot of fun with that problem too. Kappa. Oh my god. So, I mean, at least the nice thing about these hacks is that I'm basically getting points back from trolling on problem D. So in the grand scheme of things, it actually like doesn't matter as much. What the fuck is this? I don't even want to read that. That's just weird. 3.5 minutes left. Oh, I already looked at this one. It's probably okay. A frozen account. M. Okay, he does not change M. Wait, if it's all zeros, it just returns it. That's okay. He makes a set of changes and he breaks if it doesn't change anything. Okay, that's probably fine. Yeah. While k minus minus. Yeah, I already checked that one. I already checked that one. Woohoo. Okay, I'll double check this guy. Oh my god, this is... What is this code? Oh my god. Min... Okay, so min and maximum occurrence of these. Okay, as long as max does not equal to -1. So if there's at least a 1 in here. What is this? Okay, like, huh? What on earth is this? Like, do I want to know? And x is equal to m. Oh, okay, he's doing the endpoints. Oh, okay, I think I see what's going on. And I think this is correct. Yeah, that looks fine. Okay, I think this is pretty much it. Like, this is my contest. Honestly, like, this really stung. But in the grand scheme of things, I actually didn't do that bad. Like, it's not that bad at all. Like, oh, I beat second thread, Pog. Yeah, get flexed on, nerd. I'm just kidding. I don't mean any shade on you. We love second thread here. Especially because you use Java. Java supremacy. Wait. Top 3 people on my friends list use Java. Hey, I like to see that. Pog, 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 pog. Okay, yeah, but I'm done with this contest. Now, if you did well, great. If you didn't do well, then that's unfortunate. I think hopefully I don't FST anything. But yeah, that's pretty much it. See you next time.